Forces acting on well foundations. Last class I have covered, starting with your well foundation, different components as well as other part. So, depth of well foundations, and I have covered your different parts in the depth of well foundations. How much is your depth of the well should be penetrated below the ground surface. So, it should be below your maximum scour level, and based on your Lacy's formula, the normal scour depth you can find it out RL. So, scour level is equal to highest floor level minus R and highest floor level minus 2 RL. Grip length is your 1/3 of your R below the scour level. Then also there are some provision from the code, that also I have discussed, and Terjaghi's and Peck given the values to find it out ultimate bearing capacity of your well. Then what are the forces acting on the well foundations? Dead load, live load, impact load. Impact load basically due to your live load, wind load, water pressure load, longitudinal forces, centrifugal forces, buoyancy forces, earth pressure and seismic forces. Now let us start with your stability analysis. The stability analysis is basically, if there is a well here, then there are river bed below this well has been penetrated below your scour depth. Generally in stability analysis, how it is going to resist against your lateral forces, that is more important than your vertical forces. So, in stability analysis, it is your lateral stability of well foundation. So, it has been given by like seat pile or bulkheads, special type of earth retaining structures. It has been given by Terjaghi. It is called sometimes approximate analysis. So, Terjaghi's solution for free rigid bulkhead, can be used for an approximate analysis of well foundations. So, when a rigid bulkhead embedded in sand mass parallel to its original position, sand on its front is transferred into a passive. Let us see how it is happening. Let us draw the figure. This is your scour line, let us say lateral resistance is your Q prime maximum, and this is your distance H. Let us say this is point A, and then This is your E, this is A, let us say this is C, point F, this is your point of rotation O, if I put it like this, so then this distance has to be determined, let us say this is your D1, then here suppose say S, then it will be your X, and this is distance D, and total height is your from here to here, this will be your H1. So, what are the assumptions? What are the assumptions? Front, if this is the lateral forces coming, front will be passive force, because it will move like this and it will be go towards passive force. Rear, passive force or passive state. Rear will be active state. Both active and passive resistance are fully mobilized. Then net pressure at any depth Z, net pressure at any depth Z below the ground surface which is equal to P is equal to gamma Z Kp minus Ka, which is I can write it if there is a water table here, then it will be gamma summas D Kp minus Ka. Here also from this to this point gamma submerged D Kp minus Ka. Resistance force per unit length. So, Q maximum I can write it, Q maximum prime is equal to horizontal force per unit length acting on the bulkhead of total height H1. I can write it Q maximum prime resultant total pressure per unit length. Resultant pressure, total pressure per unit length, then D is equal to depth of well below this cover line and H is your Q max, H is equal to Q prime max act at a distance above this cover line. D1 is your height of point F above bottom, height of point F above bottom. For light well, there are two cases, one is your light well and other is your heavy well. For light well, it is assumed that will rotate about the point O above base B. For light well, look at the figure, will rotate about point O above base B. The pressure distribution on both the side bulkhead at the instance of failure is shown in figure. So, I can write it out. If looking at this free body diagram, Q maximum is equal to, I can put it, Q maximum prime is equal to area ABC, area ABC minus area FEC, which is equal to half gamma submerged d square Kp minus Ka minus half gamma submerged d Kp minus K1 Ka into D1. Area FEC, area FEC, if you look at area FEC, then it will be instead of half, and here it will be 2 times, here it will be 2 times gamma submerged d Kp minus K into D1. It comes out to be half gamma submerged d into Kp minus Ka d minus to D1. This is your equation 1. Then taking moment at point O, taking moment at point B, it should not be at O, it should be at point B, then Q maximum minus maximum H1 is equal to half gamma submerged d square Kp minus Ka d by 3 minus half into 2 gamma submerged d Kp minus Ka to d1 whole square by 3. This is your equation 2. Now, substituting equation 1 into 2, in 2, then what will happen? Half gamma submerged d Kp minus Ka into d minus to d1 into H1 which is equal to half gamma submerged Kp minus Ka d square by 3 minus half into 2 gamma submerged d Kp minus Ka d1 square by 3. That implies, if I solve it further, d minus 2 d1 into h1 is equal to d square by 3 minus 2 d1 square by 3, then 2 d1 is equal to 3 h1 plus minus root over of 9 h1 square minus 2 d into 3 h1 minus d. So, substituting d in equation 1, the value of q maximum can be find it out. If we can get d1, then substituting in equation 1, then I can find it out what would be your maximum lateral resistance. We can get it for particularly that well. Then how do you calculate Kp? Kp is your 1 plus sin phi by 1 minus sin phi. Ka is equal to 1 minus sin phi by 1 plus sin phi. What I have done, Terzaghi approximate analysis, what they have taken it, it is a free rigid bulkhead. Free rigid bulkhead has been considered as analysis of well foundation. If this is my well, if there is a lateral force here, definitely well will be moved towards. So, front will be passive, back will be your active state. So, net pressure P is equal to gamma z Kp minus Ka. Q maximum prime, which is your horizontal force per unit length acting on the bulkhead of total height h1. So, which is equal to resultant total pressure per unit length. So, total depth below your scour level, this is your d and this is your d1. Now, if I summation into forces, Q maximum is equal to what? The force coming here minus this force coming in this area. Area ABC, area ABC minus area FEC, area FEC. If you look at here, area ABC half gamma submerged d square Kp minus Ka, ABC half, this is your gamma submerged d Kp minus K1, this is your d. So, it will be half gamma submerged d square Kp minus Ka, this is fine. Then area FEC, so area FEC, if I take it FEC, the total B will be 2 times gamma submerged d Kp minus Ka. So, that is why 2 times gamma submerged d Kp minus Ka into d1. Where is your d1? This is height of d1. Then half base into height, that is your area, and taking moment about B. If you take moment about B, moment about at point B, here if I take moment about at the base B, then we calculate. Then substituting Q maximum, what you are getting from here equation 1 in equation 2, I am supposed to get it the value of the D1 in terms of H1 and D. Value of D1, that means this D1, where is your point of rotation, I can find it out D1 in terms of D and H. Then once you get the D1, then you can put the value of D1 in equation 1, then find it out the value of your maximum lateral load. Kpk you can get it. Then next we can go to your heavy wells. What will happen in heavy wells? Heavy wells, let us consider this is a heavy well. heavy well, what will happen? This is cover line, this is my Q maximum prime, this will be your gamma submerged D Kp minus Ka, and this is your D heavy well, particularly it is not going to rotate at the base, because this is a heavy well, it is not going to rotate above the base, rather it is going to rotate at the base for heavy wells. So, heavy wells, the assumption is rotate about base, taking moment about the base, then it will be your Q maximum prime into H1, which is equal to half gamma submerged Kp minus Ka d square into d by 3, then Q max prime is equal to 1/6 gamma submerged into Kp minus Ka dq by H1. This is for your heavy well. The next part is your effect of surcharge. If I come to the effect of surcharge, let us put a well. This is my well. And this will be your my bed, and this is cover depth. Then this will be your D, distance Q maximum prime, this will be your H, and this is my D, and total will be H1. Now, if there is a unscoured soil above the bed level, the influence is taken into account by considering earth pressure due to surcharge. It should be considered earth pressure due to surcharge. If Z is equivalent surcharge height, Z is equal to equivalent surcharge height, then Q Q maximum is equal to 1/6 gamma submerged Kp minus Ka d square d plus z divided by H1. It is self weight. For a well with length L or diameter L, the total resisting force Q maximum is equal to Q maximum into L. L is your diameter of the well. Allowable horizontal force QA is equal to Q maximum by factor of safety, which is equal to Q maximum into L by 2. So, allowable horizontal force Q maximum is equal to QA is equal to Q maximum by factor of safety, which is equal to Q maximum into L by your factor of safety. Generally, factor of safety is taken as 2. So, what I have start for a heavy well, the heavy well, the assumption is the well will rotate about base. It is not like light well will rotate above the base. From there we got taking moment about the base Q maximum, we got it. Then effect of the surcharge, we have considered the effect of the surcharge on scoured soil above the bed level. So, considering earth pressure due to your surcharge, sometimes what happen, there are soil accumulated above the scour level, it impact load, that has been considered as a earth pressure due to surcharge. Z is equal to equivalent surcharge height. So, Q maximum I got it. So, total resisting force Q maximum is equal to Q maximum into L. Allowable horizontal force QA is equal to Q maximum by factor of safety. So, Q maximum into L by 2, that means factor of safety consider as a 2. Now, what should be your maximum pressure at the base? Q is equal to actual applied transverse horizontal force. Q is equal to actual applied transverse horizontal force. QA is equal to allowable equivalent resisting force. Allowable equivalent resisting force. The unbalanced force I can write it Q minus QA acting at a height of H above scour level. Are you getting? Q is equal to actual applied transverse horizontal force, QA is equal to allowable equivalent resisting force. If you look at here, actual applied horizontal forces and allowable resisting forces because of your soil. Then unbalanced force is equal to Q minus QA, it acted at a height H above your scour level. So, overturning moment at the base at the base MB is equal to Q minus QA into H plus D. The maximum and minimum foundation pressure, maximum and minimum foundation pressure, that means F maximum is equal to W by AB plus MB by ZB, F minimum is equal to W by AB minus MB by ZB. So, W is equal to net vertical load on the well base. Net vertical load on the well base after taking account of buoyancy, and skin friction. AB is your area of the well base, ZB is your section modulus of the well base, which is equal to IB by D, IB by D. So, maximum foundation pressure always less than your allowable bearing pressure. Allowable bearing pressure. So, maximum pressure at the base you have to calculate, because whether there is a tensile or compressive, this has to be taken care of it. Otherwise, it will be very difficult for the well foundation design. So, then next part is your maximum moment in staining. Where is your staining? Look at here. Both the sides, that is your staining, maximum moment at the staining, that has to also be calculated. Maximum moment in staining. The well staining is subjected to a bending moment due to horizontal load. It is subjected to bending moment due to horizontal load. The maximum moment A maximum on the staining occurs at point S at a distance x below this cover line. Maximum moment A maximum staining occurs at a point S at a depth x below this cover line. What does it mean? That means there is your shear force is 0. That means, in that case applied force is equal to the earth pressure. That means 1 by factor of safety into half gamma sum must Kp minus Ka x square L is equal to Q. So, x is equal to 2Fq divided by gamma sum must Kp minus Ka into L. This is your half. So, taking moment about S, M maximum Q H plus X minus pressure force into x by 3. So, pressure force is equal to the earth pressure at equilibrium. I can write it M max is equal to QH plus 2/3 Qx. If M is equal to applied moment, if M is equal to applied moment which is equal to Q into H, then M maximum M plus 2/3 Qx. It is required for design point of view maximum moment at the staining. If you look at the initial phase, this is your S, maximum moment at staining S. What we have calculated, well staining subjected to bending moment due to your horizontal load Q, maximum moment M maximum occurs at a point S below this, X below this cover line. So, what will happen? Once I say there is a maximum bending moment, at that point your shear force is equal to 0. That means applied force is equal to your earth pressure. So, applied force is your Q, earth pressure, from there the distance x has been calculated. Then moment about S, M maximum is equal to this Q into H plus X, pressure force into x by 3. At the end M maximum is equal to M plus 2/3 Q into X. This is all about the theory. I will stop it here. Next class I will solve 2 examples as well as few more things. Thank you.